Astrobiology is a very interdisciplinary field, but it's very exciting because it looks at life at the limits and tries to understand whether life could exist elsewhere. Astrobiologists are also trying to find new types of microbes that could be resistant to space extremes. Can we find new microbes that would be useful in space exploration and settlement? And are we the only example of life in the universe, or are there other planets with life? These are fundamental questions, but they also have very practical implications. By learning about life in extremes, we learn about the interaction of life with our own planetary biosphere. That might tell us about the human impact on the biosphere in the future and the future of life on Earth. Or by using the International Space Station to look at the limits of radiation stress in microbes, we might learn something about whether microbes could grow under the radiation environment of Mars, for example, or in other planetary bodies. There's a couple of experiments we've done. One experiment is to expose microbes to space conditions. This is a European experiment called the EXPOSE experiment, where we take microbes onto the space station, we bolt them onto the outside of the station and leave them there for 1.5 years, 2 years, and see which ones can survive the intense conditions in space. Over a quarter of the world's copper and gold is today extracted from rocks using microorganisms. It's called biological mining or biomining. And the question is, could we use microbes elsewhere in space to try and extract elements from rocks? The bio-rock experiment was motivated by trying to understand how microbes interact with rocks. Now, you might think that's a very strange thing to have an interest in, but it turns out this is very important. For example, we could use rocks on the Moon, Mars, or asteroids to supply microbes in life support systems that might be producing oxygen or other useful elements and compounds for human existence. We also want to understand how microbes behave inside, for example, filter systems that are circulating fluids and liquids, drinking water. If you're relying on microbes to produce oxygen, for example, for your astronauts, you don't want all the microbes to suddenly die. So you need reliability. So despite the fact they can survive in extremes, we still need to understand how they behave in space and how we can optimize their chances of surviving in space conditions. If I had any wish in space exploration, it would be to try and grow microbes on the Moon or Mars and try and do the real experiments. We can do these experiments on the International Space Station, but these experiments are partly to prepare humans to go to asteroids, the Moon or Mars. So the ideal experiment would be to actually go to these places and grow microbes in the environments in which we actually want to use them.